Hello friends, in this video I'll tell you that how to perform binary search. In the previous video you have seen that how to search an element in an array using linear search, that is one element by one element searching. This method is much more faster, and binary search normally works when the elements in array they are sorted. So let's say 2, 6, 9, 10, 15, 18, 30, 32. Now these are the elements in the array, and I am interested in knowing where the element k comes. That is 80. So this is my key element which I am searching for, and its index is 0, 1, 2, 3, 4, 5. So the element is at fifth index. So what I'll do is I'll take this index as the first element's index as, or this one as L, and this index as R. Then I will do what? I'll try to find out the middle element, that is L. Let me write it below. That is M is equal to L plus R by 2. Remember, this is integer division. So this is 0 plus 7 by 2. So this will come out as 3 because this is integer division. So the decimal part will be truncated. Now, where are we? Then we will be coming to this array and searching whether the element whether the element is at mth location, mth index. What is M3? Whether the element is here? No, it is not here. Then, if the element comes at this location AM, then we'll be saying our answer is done. This is the index and come out of the loop. Otherwise, we'll be checking that whether this AM is less than K. Yes, it is less than K. Then where to search? It will always be in this direction, that means away from this number 10. So we have to shift our reference L to right. So L will be, now this plus 1 will be my new element. So L will be M plus 1. Why we have done M plus 1? Because if it is not at the location M, then it has to be on the right side of it. Okay. Likewise, if the element, let's say, again do this, M will be what then? M will be, now what is this L? M was 3, so it becomes 4. So what is M now? M will be 4 plus, we have not touched the right side, by 2, that is 7 plus 4 is 11. 11 by 2, that is 5 point something, so that will be truncated, so we are getting at element 5 itself. So now again we'll be checking that is element exist at this location. It so happens that it existed at this location, so we will say that okay, we have got it and we'll come out of the loop. But let's say somehow you started and you landed on the right side of the element. Let's say assume that we landed on the right side of the element which we are searching for. Then what? As we are on the right side of this particular element, so there is no point moving up to R. So what we'll do, if AM happens to be more than K, then you shift your right. So right will become shift to left side. So right will become the M minus 1. Okay, so this you should always do. Now, when, what is the converging criteria of this loop? When this loop will converge? So let's say it is doing every time like this, and it so happened that the left came on the right side and the right came on the left side. So if L happened to be more than R, then stop. And if you are unable to find the element till this point, then simply say after the loop that no element. It means the program is unable to find this element in the loop. So let us try to write this program. So include why it is not coming. Oh. So let us make another one. No, the extension was wrong. A dot C. Okay, now include stdio dot h into main, and then return 0. Now let us define one array. So A, and that is 2, 5, 7, then 10, let's say 14, 18, 21, 28, 31, 35, and let's say 46. So these many elements are there. How many elements are there? So who will tell? The size of. So int n is equal to, assign basically, size of A divided by size of A0. Okay, done. Now we know n. Now we have to know that particular element which we are searching for. Let's say that element is k, and we are searching for, say, 21. Okay, now we have to define the left and right. So int left is equal to 0. Okay, what about right? That will be equal to n minus 1. That's it. Because if we are starting with 0 and there are n elements, so this index will be n minus 1. Done. Then what? Then define one m also, which is nothing but the middle. Okay. Now run a loop, that is indefinite loop, while L is less than R. Then do what? Then if, now first evaluate m. M will be L plus R divided by 2. Okay. If the element at the mth index came out to be lesser than this k. If the element at the mth index came out to be lesser than k, then you shift left to m plus 1. Okay. If element at, sorry, first let us say that the element happened to be at this. Then what you will be doing is, you will be saying that you will be printing printf the element k is at location where m. Okay, so the element k is at location m, and then simply return 0. Okay, now if the element, the one which we are searching for, is not equal to am, then what? Else we have to check. Else if this particular element am is less than k, if that is the case, then your left will become equal to m plus 1. Okay, and if neither it is equal nor it is less, then it is going to be more only. So you make your right value to be m minus 1. Now if it so happened that it has run from left to right, right to left, and in such a way that L happened to be more than R, then the loop will be terminated and you will be coming out of the loop. Then outside, what you will be saying? You will be saying that the element is not in the array. What element? K. Let us run it and see. Now it is saying R undeclared. Yes, it is should be comma. Okay. Now the element 21 is at location 6. So the element 21 is at location 6. So it is 0, 1, 2, 3, 4, 5, 6. That's it. So in how many iterations? In how many iterations this has done this? So let us take one count and is equal to 0, and so every time this will run, this count will be count plus is equal to 1, and simply here I'll also write the number of iterations taken up by the program is equal to count. Okay, and this has to be written down, so a new line here. Okay, let us run it. Count, count. So the number of iteration it has taken to reach there is 3. Now imagine if this would have been linear search. So how many iterations? 1, 2, 3, 4, 5, 6, 7. In the seventh iteration. And if this would have been 35, let's see. If this is 35, then again in 3 iterations it was able to get. Okay. Whereas that would have taken, that is linear search would have taken longer time. So friends, in this way, we can perform the binary search, okay, and with the help of this, now you are also familiar with a way of searching an element in an array. This particular method is very similar to the root finding method which we perform in numerical mathematics, and that particular method is called as bisection method. So there is no difference between uh, bisection method and the this binary search. They are more or less the same. So in this video, till this point only, hope that you have learned it. So thank you very much for watching it.